Hi everyone, in this video we are going to discuss about solving quadratic equations by completing the square. Now in a previous video we have explained how to solve quadratic equation by factoring. When the quadratic polynomial can be factored easily, then factoring would be the ideal way to go. But sometimes the quadratic polynomial may not be easy to factor. In that case, we have to find some other way to solve it, right? So let's take an example first and let's see how it works. So our first example is like this. Suppose we have a quadratic equation which is say x squared plus 4x minus 1 is equal to 0 and x belongs to a real number or x belongs to the real number set. That means x must be a real number. That means solution must be a real solution. Now before we go any further, first thing we should do is we should quickly check the discriminant and see how that looks. So in this case discriminant would be b square minus 4ac. So that would be 4 square minus 4 times a times c, and that will be equal to 16 plus 4, which is equal to 20, that is greater than 0. So in this case discriminant is positive, and discriminant is positive means the roots will be real. So we have real roots, that means the necessary condition will be satisfied, so we should be able to solve this equation. So let's try that. So our original equation was x squared plus 4x minus 1 is equal to 0. That was our original equation, and from here we can say, okay, can we write it like this? Let's say we write x squared plus this 4x term, I'm going to write it like this, 2 times x times 2. And then if we had a 2 squared, which is not there, I know, but I'm forcefully writing it. So if we had a 2 squared and then we subtract the 2 squared, then our equation is still valid. I forcefully added something and I subtracted it, and then we have minus 1 is equal to 0. So this is the only extra thing that I introduced here, and ultimately this is nothing but 0, because positive 4 and negative 4 meaning plus 4 minus 4, that means I have really not changed anything. But introducing this extra thing is going to really help in our process here. So now from here we can say that the first 3 terms, now if you look at the first 3 terms here, which is this portion right here, this actually looks like x plus 2 whole square, right? And then what else we have? We have minus 2 squared, which is minus 4, and then also a minus 1, that is equal to 0. So from here we can say that x plus 2 whole squared minus 5 is equal to 0. From here we can say that x plus 2 whole squared is equal to 5. From here we can say that x plus 2 is equal to plus or minus square root of 5. And then from here we can say, okay, so x is equal to negative 2 plus or minus square root of 5, and there are those two values. One would be negative 2 plus root 5, the other one would be negative 2 minus root 5. Those are the two possible values here for x, right? And also instead of doing it like this, we could have solved it this way also. So let me quickly show you right here. So I'm going to make a quick note right here. So from here we could also say that x plus 2 whole squared minus the 5 that we have, can we write it as square root of 5 whole square, that is equal to 0. Now you see we have a nice form which is like s square minus b square. This s square minus b square form is the form that we originally wanted to arrive at to solve this equation, right? So from here you see that we can say, okay, now that it is in the s square minus b square form, so we can say a plus b times a minus b, that will be the s square minus b square. So here we can say, okay, x plus 2, that is the a, and then plus b times a minus b. If we assume this portion to be a and this portion to be b, then you can clearly see that this is like a squared minus b squared. So a square minus b square is actually a plus b into a minus b, a plus b times a minus b, and that's exactly what I have done here. So x plus 2 plus root 5 times x plus 2 minus root 5. So from here we can say, okay, then our two factors are like this. That means each of the factors could be 0. That means x plus 2 plus square root of 5 that is equal to 0, or we have another possibility that x plus 2 minus square root of 5 that is equal to 0. So from here we can say, okay, then x could be negative 2 and minus root 5, or x could be negative 2 and plus root 5. And that's exactly what we got originally also. So now in both the cases we still got the same root and it's working out exactly the way we wanted. So this is how we do the completing the square method, meaning we first try to create the difference of two squares and then from there we do the factorization. So I'm going to highlight right here. So this is nothing but a difference of two squares right here, and then we do the factorization. Because as soon as we can convert our quadratic polynomial into a difference of two squares, then factorization is just a piece of cake, right? So once we are able to factorize, and then it's very easy, then we equate each of the factors to 0 and then from there we find the value of x. And in this case both of them are real number, there is no imaginary part, both of them are real. So this is a real solution, and those are our two solutions of this quadratic equation. Now let's take a second example. Suppose our second example is x squared minus 2x plus 5 equals 0. And here suppose let's take one condition here. Let's say x belongs to the real number set. If this is the provided condition here, then first thing we should do is we should quickly calculate the discriminant and see what is the discriminant here, right? So here discriminant is equal to b squared, which is negative 2 squared, minus 4 times 1 times 5, 4ac, b squared minus 4ac. That means 4 negative 2 squared would be positive 4 and minus 4 5 is 20. So this is actually negative 16 and that is less than 0. So in this example, you can clearly see that the discriminant is negative. That means the roots are complex number. They are not real number. So if you are asked to solve this quadratic equation for real roots, then our answer will be that this equation has no real solution. However, if we are given the equation like this, I'm taking the same equation, x squared minus 2x plus 5 is equal to 0, but we are not given the additional condition here that x must be a real number or whatever, right? So without any condition, that means if x could be real or complex or imaginary, then we can probably try and solve this quadratic equation, right? So let's try that. We already know that the discriminant is negative. We already know that the roots will be complex roots. There will be an imaginary part in the root. So with that knowledge, let's proceed and see how it works out. So now let's try to also do the completing the square method for this particular quadratic equation, because we cannot easily factorize this equation. So our next step here would be, we can say, okay, x squared minus 2 times x, and then maybe we can say times 1, because our negative 2x can be written like this. And then we can say, okay, how about forcefully writing a 1 square here and then subtracting a 1 square. So forcefully we added 1 square and then we subtracted the 1 square, and also we have the positive 5 that we are keeping here. And then and also you could have borrowed 1 from the positive 5 also. You could have done that also, but again, let's keep it simple. Let's do it like this and let's see how that works out, right? So in this case, now if you look at this portion right here, this is clearly x minus 1 whole square. And then what we have? We have a negative 1 and a positive 5. So that is equal to 0. From here we can say, okay, x minus 1 whole square, and this will be plus 4 is equal to 0. From here we can say, okay, x minus 1 whole square plus 4 is actually 2 square. 4 is actually 2 square, that is equal to 0. But now you can see that we could not come to a picture which is like a square minus b square. So this picture looks like a square plus b square. And there is no easy way to factorize a square plus b square, because you see it's like something square plus something square, right? So now we are in a situation where we cannot really factorize this thing. We actually, if we had something like this, like an a squared minus b squared, then yes, then we could easily factorize this thing as, a plus b times a minus b, right? But now we have arrived into a picture, or we have converted the quadratic polynomial into a picture which looks like a square plus b square. So what do we do now? Well, this is where we are going to do a quick little trick, and we are going to forcefully convert this thing into a square minus b square form, and let's see how that can be done here, right? So now let's say, okay, for the first term is x minus 1 whole square. So we are keeping that as is, and then I'm forcefully putting a minus sign. I'm saying that, okay, can we do like this? So can we say negative of negative 1 times 2 squared? I'm keeping the 2 squared, and all I did was I introduced a minus sign, and I am now multiplying a negative 1 with the 2 squared. So now you see this negative 1 and the minus sign, that will become positive. So our original equation is still intact. We really haven't changed much with the equation. The equation is still in balance, right? So now from here you can see, so we can say, okay, let's keep the first term as is, x minus 1 whole squared, and then minus this negative 1. Now in complex number, you know that square root of negative 1 is actually indicated by the iota sign, which is like a lowercase I. So square root of negative 1 is actually the iota, right? And if you square both sides, then from here we can say, okay, negative 1 is equal to I squared, because square root will disappear when we do the square, meaning square root. So let me again write it like this. So if we want to do square of the square root of negative 1, it will be like this. So from here we can clearly say that negative 1 is equal to I squared. And that's the technique I am going to use right here. So here we can say, okay, this negative 1 can be written as I squared, and then we also have the 2 squared. All of this is equal to 0. And then from here we can say, okay, x minus 1 whole squared minus this I squared and 2 squared. Can we write them like 2 times I whole squared? Because they both have a power 2. I also has a power 2 and 2 also has a power 2. So we are writing them like 2 times I whole square, that is equal to 0. From here we can say, okay, now we have a square minus b square form. You can see that, right? X minus 1 whole square minus 2 times I whole square. So this is like an a square minus b square form. So from here factorization is really easy. So now what we are going to do? We are simply going to use the a plus b times a minus b form, right? So now if we say, okay, x minus 1, that is a, plus b times minus b, that is equal to 0. And from here we can say that each of the factors could be 0. So x minus 1 plus 2i, that can be 0, or the second factor, which is x minus 1 minus 2i, that can be 0. So from here we can say, okay, x could be positive 1 and minus 2i, or x could be positive 1 and plus 2i. So these are our two solutions right here, and they are obviously complex number. They are not real number. There is an imaginary part in the solution, and complex roots always come in the form of complex conjugates, because if you see, the imaginary part is positive in one solution and negative in the other solution, and they are actually conjugate of each other. So that's why we say that imaginary or complex roots, they always come in complex conjugate form, right? So if one is 1 minus 2i, the other one will definitely be 1 plus 2i. So that is how we solve quadratic equations, even when our discriminant is negative, even when we know that our roots will be imaginary. We can still bring the quadratic polynomial into an a square minus b square form, and then factorize and then solve it. I hope all the steps made sense. Thank you for watching. See you in the next video.